Thanks, Arthur. Great to be here. I'm also a professor of statistics at Wharton, and I spend much of my life sort of doing the interface of finance and statistics and economics and statistics. And it's hard these days, as you know, to do that without bumping into climate. It's sort of everywhere in terms of climate finance, macro climate, and so on. And lately, I've gotten into climate, and we've been working, I and some team members have been working on Arctic sea ice, which sounds a little bit exotic. It might be for you, it is for me, but it's actually fundamental to a lot of things because Arctic sea ice is sort of like a window into the future. There are amplification mechanisms that have caused it to warm and continue warming 2 to 3 times as fast as the global average. And as you know, the global average is itself problematically increasing. So I thought I'd show you a little bit about that today. Of course, everybody knows that global climate and temperature increases in particular lead to sea ice melting. No big surprises there. But the feedback mechanisms amplify that. As things warm and sea ice melts and permafrost melts, well, the albedo, the reflectivity of the Arctic drops. You know, snow and ice are kind of white, and open sea is kind of black, and that absorbs a lot more heat, right? And simultaneously, as permafrost melts, it releases methane, which is way, way worse than CO2. So you've got all that going on, and that leads to so-called Arctic amplification. Now, this is very geophysical, this piece of work that we're doing here. It's the kind of thing you'd see in nature or science. Right at the moment, it's not so economic or so financial, but we have definitely in mind sort of motivational issues that we're going to get to as soon as we can. It's just a question of getting the facts straight first. So right now we're trying to get the facts straight. But think about various costs and benefits of Arctic warming. Of course, we all tend to think a lot about the costs. You know, increased emissions increases warming globally. There's environmental damage due to particulates and discharges and spills and soot deposits. You know, there's a lot of negative stuff that goes on with warming. And then as the planet warms more broadly, of course, the sea level rises as land ice, not sea ice, but land ice melts and so on. But there are benefits, of course, economically as the Arctic opens up as well. You know, we all might have different views about how they trade off, but there are going to be newly accessible deposits of natural gas, petroleum, other sorts of natural resources, fisheries, things like that. In addition, and crucially from a global trade point of view, as the Arctic sea ice melts and trans-Arctic shipping becomes possible in August, September, October, kind of reliably possible, you know, that's going to cut the transportation time and cost from something like Rotterdam to Tokyo in half. You know, so this is a big deal potentially for global trade. And there are lots of geopolitical aspects related to that. You know, who owns the sea lanes? And who says you own them? I say I own them. And you know, you can see a lot of stuff that is already happening, but it's going to continue happening. And so, you know, we've got some papers on this. The first paper is all about projecting business as usual in a statistical econometric way. And much as it pains me to distill a paper into one little picture, this is it, right? So the white area is history. The gray area, starting where we are now, is the future. And under business as usual, you can see the sea ice hitting zero, and zero isn't even the most interesting thing because, you know, sea ice is never going to be exactly zero. There's sort of land-fast ice and so on. So people tend to talk about a nearly ice-free Arctic rather than a totally ice-free Arctic, where nearly means about 1 million square kilometers, not zero. So that would be here, right? And that's like in about 2040. And it turns out that this is incredibly robust to lots of things that you can do that I won't go into now, but I'd be delighted to talk if you're interested. So in the most recent research, we say, well, wait a minute, there's not just sea ice area, there's also extent and volume and thickness, and these things are all related. And when any one of them hits zero, they all must hit zero. So we can bring a lot more information to bear on the problem by modeling these things together or in pairs, and that's what we've been doing. And you know, by constraining the ice-free Arctic, say in this case for area and extent at the same time, which we know must happen, we can refine the predictions. Here we've moved into a so-called carbon trend as well. So we're projecting gigatons of carbon, what's that going to be when we hit an ice-free Arctic? If we run through that through some of the so-called SSP scenarios, different scenarios that people use for thinking about future emissions, we can get out the projected trends that sort of match up what we were looking at a minute ago. And you can see same sort of thing, near ice-free Arctic in about 2040. We've got a lot of dialogues going with the climate people. They used to say, you're crazy. You're telling me the ice is going to be gone much sooner than our models do. And I would say, well, maybe your models need a little bit of rethinking. And now they tell me, well, this is obvious. Everybody knows this. Things, damned if you do, damned if you don't. But we're working on it. So.